Assalamu alaikum and good morning everyone. We will going to present Farmer Lots Theory presented by IBTIHAL AHMED MAYYADAH. Well now IBTIHAL will going to start to the intersections.
Fermat's last theorem, Introduction to the Problem. The 17th century mathematician Pierre Fermat created the last theorem, which became one of the most chilling problems in mathematics. The theorem states that the equation x power n plus y power n equals z power n has no positive integer solution for x, y, and z, where n is an integer greater than 2. In the margin of a mathematics book that Fermat read, he wrote down, "I have a truly marvelous demonstration of this proposition, which is too narrow to be contained is the margin." Although x squared plus y squared equals z squared has an infinity number of solutions, but x power n plus y power n equals z power n has no non-trivial whole number solution for n greater than 2. For example, we can easily check to see that 3 square plus 4 square equal 5 square, and 5 square plus 12 square equal 13 square. Try as you can, but you cannot come up with integer values for x, y, and z such that x power 3 plus y power 3 equals z power 3. Proofs for special cases. Fermat has given the proof for n equal 4. He tried to prove that the area of a right triangle with rational sides is never a perfect square, a condition that is equivalent to the claim that there are no integer solution to x power 4 plus y power 4 equals z square, and hence no solution to x power 4 plus y power 4 equals z power 4. Fermat's proof for n equal 4. Fermat studies the following equation: x power 4 plus y power 4 equals z square, and showed that this equation has no solution in all integers not equal to 0. Suppose x power 4 plus y power 4 equals z square has solution. Let x, y, z be a positive integers such that x power 4 plus y power 4 equals z square. Then GCD xy equal 1. Assume b divides x and y. Then x equal bk and y equal bk dash. Then b divided x and b divided y. b divided x power 4, b divided y power 4, b divided x power 4 plus y power 4. It proves b divided z square. Now let x equal b x dash and y equal b y dash. Then x power 4 plus y power 4 equals b power 4 x dash power 4 plus b power 4 y dash power 4 equals b power 4 z dash square. And therefore x dash power 4 plus y dash power 4 equals z dash square. We assumed that x is the small set number for which the equation holds. Now found x dash greater than 0 less than x, and the equation holds for x dash, which is a contradiction. Hence, equation has no solutions. Fermat further connected the above results by a corollary to prove that x power 4 plus y power 4 equals z power 4 has no solution in integers, all not equal to 0. Euler proof for n equal 3. Let x plus y equal to u, and let x minus y equal to v. Then 2x equal to u plus 2v, then x equal u plus v, and 2y equal to u minus 2v, then y equal u minus v. The equation minus z power 3 equals x power 3 plus y power 3 equals u plus v power 3 plus u minus v power 3 equals 2u power 3 plus 6uv square. It implies that minus z power 3 equal 2u multiply u square plus 3v square, where u square plus 3v square is odd and z is even. Therefore, GCD to u u square plus 3v square equal 1 when u is not divisible by 3, equals 3 when u is divisible by 3. Now, if GCD to u square plus 3v square equal 1, then by unique factorization theorem, 2u and u square plus 3v square are cubes. That is 2u equal a cube and u square plus 3v square equal b cube. According to K lemma, we can write u equal c cube plus 9c d square and v equal 3c square d plus 3d square. This is where the Eulers had the gap. Now, if we consider K lemma of this theorem, then D is odd and C is even since V is odd. Then A power 3 equal to U equal to C multiply C minus 3D multiply C plus 3D. Now, because the three factors on the right hand side are pairwise comprime, they must all be a 3 power. 2c equal minus n power 3, c minus 3d equal I power 3, c plus 3d equal m power 3, where I, m, n are distinct and pairwise relative prime. Therefore, we conclude that n power 3 plus I power 3 plus m power 3 equals 0. But absolute value z greater than absolute value m, because absolute value z power 3 square absolute value 2u multiply u square plus 3v square greater than absolute value n power 3 because c square minus 9d square equal
Assalamu alaikum. Thank you for IBTIHAL. So now I'm going to start with infinity descendant method. This method is known as method of infinity descendant, created by Fermat, in which you assume that you have the smaller solution for a problem and show that there are still smaller solutions. In other words, there is no smaller solution, and if you continue working on this, and there is no solution at all. Although Fermat proved the theory for n equal 4 by using the infinity descendant method. This method does not work for volume n larger than 4. Sophie Germain. In early 18th French mathematician Sophie Germain adopted a new strategy to approach FLT according to Sophie Germain in F and 2n plus 1 are primers, then x to power n plus y to power n equals z. N implies that one of x, y, and z is divisible by n. Hence, Fermat's last theory could be broken into cases. Case 1, none of y, x, z is divisible by n. Case 2, one and only one of x, y, z is divisible by n. She has proved the theory for Sophie Germain primers to by small 100. Further history. In 1825, Legendre had floored the Sophie Germain criteria and proved the first case of Fermat. Last theory holds for every primer P smaller 197. He was also able to prove second case. In 1832, Peter Legendre proved the theory for n equal 14. In 1839, Gabriel Leimer proved the result for n equals 7. Specific cases are proven in 1909, 1915, and 1953, but still no one is able to come up with the completed proof the FLT. In September 1955, a 20 years old Japanese mathematician Tanima Shamur claimed that all elliptical graphs are modular. In 1985, Gerhard Frey, German mathematicians, considered the unthinkable. What would happen if Fermat was wrong and there was solution to this equation? Frey's idea became known as the epsilon conjecture. Frey should had starting with fictitious solution to Fermat's last equation could make an elliptical graph with some very weird proposition. That elliptical graph is made to be not modular, but Tanima Shamur said that every elliptical is modular. So it means if there is a solution to this equation, it creates such a weird elliptical graph. It defies Tanima Shamur. In other words, if Fermat falls, so did the Tanima Shamur. If Tanima Shamur is correct, then Fermat's last theory is also true. In fact, Frey was the first mathematicians who built the bridge between GHANIM, conjecture, and Fermat last theory. Ken Repeat, a professor for University of California, with the help of Barry Mazur, latter of proffered this result. Now FLT is linked to the GHANIM guesstimate. In June 1993, Andrew Wiles has proved FLT. In September 1993, an error has been found. In September 1994, Andrew Wiles resolved the problem with his former student, and Fermat's last theory has been proved.